this is a very quick agenda because it's about a 30-minute talk. I hope to leave time for questions at the end. If I do not, just find me in the hallways and I'll be glad to speak to you about what you might find interesting. Or you can educate me. So when I was creating this presentation, not too many days ago, I like to do research and make sure that we have definitions and facts that we all start from. So I found this report that Seagate commissioned. Seagate's a hard drive company. I didn't even know they're still around. But they commissioned this report by the IDC to talk about data. And of course, with machine learning, you need data. So I found this fact very, very interesting that last year there was about 33 zettabytes of what they call the global data sphere, which is basically like usable data, not necessarily every single copy of that same piece of data, but something that's being created either by IoT sensors or actions online or consumers or whatever it might be. And then it's going to grow to 175 zettabytes in 6 years. So I was like, well, it's a really impressive number. What does that mean? So instead of doing my own calculations and trying to remember computer science from like forever ago, I went to Wiki and it figured it out for me. So I'm looking at 1 trillion gigabytes because that's like the thing that I can grasp. And so we were at the VMware booth, we were handing out these USB sticks. And the USB stick was 32 gigabytes. And so I did the math. That would mean you would need, I don't know, it was like 1.275 trillion of those USB sticks to equal 1 zettabyte. So that's a lot. So you think about, we have at least that much data now. So when folks talk about machine learning and wanting to use data to do interesting things, don't think that it's necessary that we need to go out and create new data. We've had data for years. It might not be in the format that we like. It might not contain all the information that we think we need, but it's an awesome starting point. There's no reason that we can't start from there. So how many folks work for a company that's using machine learning now? Pretty much everyone. Who's a data scientist in here? Would you like to come give this presentation? All right. So as most all of you working for a company that uses machine learning, you know that machine learning is a necessity. There is no way that humans can keep up with all the variables and all the options in the world. We need to let computers do this work so we can free up our minds to do other things that are creative. So companies that are not using machine learning probably will not be around in the next few years because either their competitors will do so or a startup will show up and displace them. So now we need to figure out how to use all this data. So I like, again, definitions. I found this very interesting, that the concept of machine learning was first formed in 1959. I was not alive then, just to be clear. It's close. No. So machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. So a lot of times people use machine learning for things like facial recognition. So an example of this, of being explicitly programmed, you'd have to go to all, I don't know the exact numbers, 6, 7, 8 billion people on the planet and identify each of their eyeballs. And you would tell the computer, these are 6 billion different pairs of eyeballs, and that would be the explicit programming. Whereas with machine learning, you would teach it to identify a pattern in which it could probably identify an eyeball in somebody's face. So if we think about our zettabytes and zettabytes of data, and we want to do explicit programming to make this data useful, well, it's pretty much impossible. It's very hard. So that's why machine learning is so important. We need to find patterns in this data and make it useful for our businesses. And so we want our machines to do that work because they have a ton of computational power that's just hanging out doing nothing. I work for a virtualization company, so I can say that. Computers are sitting around doing nothing. All right. So for folks that are data scientists, I apologize for this gross oversimplification of what machine learning is. But to do machine learning, you need to create a machine learning model. There are definitely options online if you go to GCP or AWS or Azure or Salesforce or IBM or enter another company that does machine learning models. There are definitely options out there for you to consume their models, or you can create your own. And that's where language or platforms like TensorFlow and PyTorch come in. But then once these models are created, then you ingest a very, very large data set to be able to train it. And then that's how we identify trends. So I'll go into this in a little bit more detail. However, models are only good as the data they're based on and trained with. So this is why we see a lot of bias and failures in ML today. So when I get into the examples, I'll talk about the good and the bad and the sort of creepy ones, like the Big Brother stuff. Who's read 1984? Yeah, that kind of stuff. That's out there, unfortunately. But to give an example, who heard about IBM Watson not doing very well diagnosing cancer? It didn't do very well, to be clear. And if we think about it, IBM Watson, obviously they have different models, but they never built a model explicitly for cancer and for medical treatment and for diseases. So instead, we took something that was meant for general pattern recognition, not we, IBM did, took something for general pattern recognition and then tried to feed a bunch of data that was very specific, a very specific industry, a very specific type, and expected to be able to identify those patterns when it wasn't built for that. So I live in Colorado. A lot of you from around the world, but Colorado is a state about a 2.5-hour flight away, and we have snow. And I also like cars. So most people that live in a state without snow or in areas without snow like here, you get these all-season tires. And all-season tires in your car are decent for the dry, decent for the wet, decent for the snow if you're in it like maybe once a year, but it doesn't excel in any of those areas. So in Colorado, when the snow is going to show up, I put snow tires on. Those snow tires are built specifically to have better traction in the snow, better flexibility below 40 degrees Fahrenheit, and other characteristics. So if you think of machine learning models as different types of tires, if you go to a public cloud provider or a company that provides machine learning models, you're always getting that all-season tire. So if you have this very specific use case where you want really good traction, you want to identify diseases, you want to do something very specific to your industry, that's when maybe you're going to build your own model. You're partner with a company that builds their own model for that snow tire. Also, because they're only as good as the data they're trained on, I think there's two levels of bias in this. So who heard about Amazon creating an ML model for hiring and that not going very well? Some people, right? So what happened was some team inside Amazon decided, hey, we're going to create a machine learning model. We're going to ingest a bunch of resumes that look like a good employee, and we're going to use that to pre-screen our candidates and then be able to interview those folks. So what happened when they implement it? They found a bunch of white dudes. Hey, these are the best candidates. Well, why? One, because their data set was white dudes, right? So that meant that the machine learning model learned that that is best. It's not that the model itself has any bias against anybody else. It's just like, hey, this is the data it was trained with. In addition to that, I think bias also lies within the team. Why didn't they think of choosing other resume types of different people? So you want to think about, even though these are models, you can think of models like small children. You're teaching them one specific task, but they're only going to learn best when you have a team that has different viewpoints to teach them. And then you have that very large data set that represents everything that is a possibility, not just what looks good for one small team. All right, so we need data. We already have zettabytes and petabytes of data, but it's still being generated. I'm sure all of you are generating some data right now. If you have opinions about this and you're posting it on Twitter, or you are taking notes or whatever, you are generating data, right? There are tons of businesses that have IoT. If you were in this room earlier, we listened to the Home Depot talk about all the things that they do, and you can imagine they generate a ton of data. So we'll go into some of those businesses, but let's think about what happens. One, you have, smart cars, airplanes, windmills, ships, all those things that companies are running to help our world, but all those things are creating data. We talked about the consumers and the tablets and the phones and everything else. Or you might be running an app, maybe in somebody else's public cloud, maybe in your private data center, so your private cloud, some sort of hybrid version of that. If you're running an app and somebody is interfacing with it, well, then you're generating data there. And then edge computing just means that it's a cloud that isn't in a primary data center. So public cloud is is compute that's not your data center, and private cloud is compute that is your data center. So edge computing is like warehouses or retail stores or manufacturing plants or things like that. So this data is everywhere, and for us to use the correct models, to be able to create the models and then use the models to do interesting things, we need to work through this process. We need to get all the data in one spot usually to be able to create the model, and then we need to be able to deploy the models to the locations where this data is being created so we can act upon it. So here's an so if we think about the goals of ML in business, maybe you have some other ideas. It would be awesome to share it with the people at the conference. But really, you want to understand your customer because you want to be able to proactively recommend services for them that they don't even think that they don't even know about. They don't know that they want. So it can be tangential to your business. And also, you want to remove all waste from any process. So I have a Six Sigma background. That's why I use the term waste. But really, waste in that sense means like movement, inventory, management, transportation. So any time that you are touching something and somebody else is touching it and somebody else is touching it, well, then that is waste. You're not efficient in your process. So a good example of this is, VMware. We're a software company, right? And we create a ton of products that hopefully a lot of you in the room use. And so, of course, there's going to be performance, and there's going to be errors, and there's going to be issues, and there's going to be interesting things. So what we do is if you opt in, or don't opt out at least, we will collect all this analytics data and put it into our cloud. And that way our engineers can say, across hundreds of thousands of customers, or tens of thousands of customers, depending on the product, how did this perform? What are the values that we saw? So if we tried to do this manually, we'd have to say, hey, customer, can you upload your log files? Or, hey, customer, can you upload your performance stats? And then all 1,000 different engineers in the company might be asking to do that, or product managers. And then somebody might put it in a database, and then they might say, oh, let's do a Tableau report or something like that. And so that's so much waste. There's so many people trying to do the same thing and spending so many hours and manually trying to look at it. If we can say, hey, we know it's performance data, we know it's logs, we know it's errors, whatever it might be, we can create a model that forms a pattern, and we can put that into an automatic process where we're downloading that data, using machine learning models to understand it, and then we can act upon it. And humans are not involved in that process. So machine learning is about understanding what people need, and then also improving your own company so you can react quickly. So what does this look like from like a real world example? Before I joined VMware as a customer, so I was like a server storage admin, a technical architect, an enterprise architect. I do have a degree in computer science. Coding is like the worst experience for me. I try and do something, it does not do what I told it to do, or I thought I told it to do, so I just don't bother. Luckily, there's a lot of other smart people that do that. So one of the jobs that I had, I worked for a manufacturing company that did insulation roofing tile. And so when you make insulation, I'm sorry if this example is not exciting, but when you make insulation, you always keep the material extremely hot in the first part of the process. So you have this gigantic vat, and you put all the mixture into it, and you keep it very, very hot, because as soon as it cools off, then it forms insulation. So if we're going to understand if we are the best manufacturers of insulation, we want the highest quality product with the least amount of waste. So we don't want to lose material, we don't want to use too much energy to heat it up to a temperature it shouldn't be, etc. So we took a very basic example. We're going to have our IoT sensors collect what are the temperatures at a different point, entering the vat and exiting the vat and in the vat. We're also going to use our IoT sensors to identify what is our mixture. And then, of course, we want our IoT sensors to measure at the end of that assembly line, what does our product look like? If we have our specs from here to here, is it right where we want it to be, or we have moved beyond our standards of quality? So once we've obtained all this data, of course, on process lines and manufacturing plants, they're already making some changes at that time. But really what we want to do is we have manufacturing plants around the world, right? We have 30, 40 different countries, different locations, different materials, different humidities, different people working the lines, different opinions, right? So we want to take all this data from the edge being the compute locations in those manufacturing sites, and bring them back to the cloud. Private, public, doesn't matter. But that's where we're going to bring all the data, because that is that large data set, whereas a single location would be a small data set. So then we want to understand the data. So back to that example of snow tires versus all-season tires, we need to make the decision, is this data unique enough that I need to create my own ML model? Say it is. So the process of creating an ML model is so not sexy. It is like the boring thing you could possibly do. And for folks that are data scientists, you know that you spend hours and weeks of your life looking at data and labeling it. So the problem with creating ML models is you're training it with data. So if it's garbage in, it's garbage out. Your model's just going to be wrong. So you need to make sure the way that you're forming your model and the way that you are inputting data into your model is correct. So I have a team that's building an ML platform internally at VMware, and we're like, oh, we're moving along, things are going so well. And we go through some testing a couple weeks later, and we're like, we fed it bad data. So then we just lost 2 weeks of work and then some more work while we had to rebuild the models and continue. So the folks on my team, there's 3 or 4 of us that all we do is we look at data of the examples of the platform, of what we want that platform to understand and interpret and output, and we say that's a VMware product, that's a VMware customer, that is a feature, that's an issue, and we go through and we label this by hand or with a tool like Brat or something like that. Obviously not by hand, but virtually by hand. And then that way we have these gold standards. There's other tools like Snorkel from Stanford, which uses machine learning to do labeling. So what we did is we used our gold labels from Brat that we did by hand to teach Snorkel to be able to label the rest of the data. That's the most technical thing I'll say. I'll move on. So you want to make sure that your data is very, very clean and exactly what you want it to do. So then you train your model, and in this case, we're going to identify variations in temperatures and mixtures and see, hey, this is the type of installation that we want to produce. So if we have all this data from across the globe in these different plants, then we can start to identify these patterns. And really, that's what this model is doing. It's identifying patterns in the mixtures and the temperatures, and of course, the other values that we'll input further. So the thing that's also interesting about machine learning, that to me, which goes back to that bias thing, is a lot of times what happens is people have a theory, or they have an idea of what they think the lack of standard deviation should be, and then they try and build their models to that point. And so I have a slight issue with that, because it's like we're assuming we know the answer. But at this point, we're just trying to teach machines to think the way that we do. And I'll give a couple examples how that didn't quite work out in different areas. But basically, you're going to test your ML model with new data, not the data that you used to train it, because that's cheating, right? You already have the answers to the test. So you take new data and you test your model. If it's not as accurate as you wish, well, then you go back to the beginning and get new labeled data and rebuild your model and change some of your parameters. And then when you get to the point where you feel it's successful enough, then you deploy it to production. So now we have our edge computing out in our different manufacturing plants, and through this information we can say, all right, now we are quickly reading these IoT sensors. Our ML models can understand what's good, what's off, and then you can quickly run some serverless code or something else to be able to adjust that process line quickly. So another example that might be more tangible is a couple years ago, Hershey Company decided to use, I think it was Azure's data analytics platform, some ML up there, and they use the same type of values like mixture and temperature and everything of Twizzlers. And they were able to, without any data scientists, do this themselves from their manufacturing plant in one location through the reduction of waste, save like $300,000 a year of making Twizzlers. So you can imagine how this can apply to pharmaceuticals and really anything else that needs to be created. So let's have some more fun examples. One of them is retail. So this is McDonald's. No, I don't eat at McDonald's. But you can see I stood there and took a picture, so you're like, Amanda, you're lying. I was at a gas station, I had to go use the restroom, and I was like, oh, this is also a McDonald's. And then I saw this thing, and I'm like, wow, you can order your own McDonald's like in the store without interacting with humans. And I'm like, that's cool. So then I started thinking about it, and I looked online, and McDonald's has an app. Like, you can actually order your food from McDonald's and walk in and pick it up or sit outside in your car, and they bring it to you. I was like, this is so fascinating. But this means, like, if I'm standing in front of this screen, one, they can have a camera and they can identify me, right? Two, if I have a unique identifier of some type, whether it's a QR code or a customer member number or an app on my phone or whatever it might be, they start to get data about me. Amanda, you always order that ice cream thing. Or Amanda, you always get a Big Mac, or you only like six nuggets instead of 9, or whatever it might be, right? And so they start to see this pattern. And if they create these models to identify these patterns, then they can start doing things that will build their business. So then they can say, hey, Amanda, you ate junk for the last 5 visits. Why don't you try a salad? Or, or maybe it's, oh, you really like this ice cream. Do you want to try a different flavor? Or something like that. So you can imagine that, okay, now they've chosen the data. If the identifier is my face, then we can move to camera bean when I walk in the store. And all of a sudden, when I walk in, now I get alerts on my phone. Hey, Amanda, we have a coupon for you so you can get 2 ice creams. Or, hey, we have this new offering, or why don't you try this? And so as they learn the pattern of me, and I'm just one of the billions of people in the world, if they create machine learning to be able to do that automatically, then they can serve their customers very well, and this can apply to any retail space. Like I said, I'm in Colorado. We had this thing called a bomb cyclone last week. Really ruined my travel. So there's this Colorado Department of Transportation has a website and, of course, a Twitter account. Obviously, it's a Twitter account I follow because I took this screenshot. But I found this really, really interesting, as I never noticed before, that these are snow plows. For people that don't live in places that snows, there's these trucks with these big things on the front, and it pushes the snow off the road so people are less likely to have accidents. They still have accidents all the time. So that's why I like to check the site to see what roads are closed, what's happening. And so when I pulled up my Twitter feed, I'm like, wow, that is so cool. All of a sudden, a snowplow is an IoT device. Well, it probably has multiple IoT devices on there for the function of the plow itself. You know, how many miles are on the engine? How are these? What are the tires looking like? What are the ball joints, or the other connections, or the hydraulic lines, or whatever it might be? That's all IoT, and that's all data, right? You can see how often do I need to take a snowplow off the road for what type of maintenance, and then you can learn to do proactive maintenance schedules. But now you also have these things driving around every city street, every interstate, every road that most people travel, and now you can use this to collect other information. And that leads into smart cities. So you don't necessarily need a moving device, but in a smart city, you might say, how many people are walking through this location? Do we need to improve the roads? And so you start to create these models that can then understand traffic flows and quality of the city, and do I need more lights here, and things like that. So really anything that you want to improve or understand in the world, as long as you can see that there's a pattern to it, you don't have to exactly say what that pattern is. The machine learning model is created in a way that it will find the pattern for you. Gambling. So we have this, obviously we have conferences for our company, but we do this thing every year called Sales Kickoff. I don't know if it's every year, but they asked me to come speak, so I was there to give a presentation. I did not take this photo because I do not gamble, at least not on slot machines, but one of my colleagues did, and he posted on Twitter. And I retweeted it, and I'm like, this is why you need edge computing. But, because edge computing means it could connect to the server on site rather than somewhere in the cloud it couldn't get to. But really, if we go back to similar to the retail model, if I'm in gambling and I have an identifier, this is Amanda, you know, how much money does she spend every day? Which slots does she sit at? How many credits does she usually play? Et cetera, et cetera. So that way these casinos can say, hey, Amanda, we have an offer for you. You have free credits over here. If I haven't come back in 2 days, I'm usually there every day, whatever it might be. I'm not there every day. I just got a look of concern. No, I play craps. I'm not there every day. But really it's about understanding the pattern of the people in there and then also offering those tangential services. So Amanda, you haven't gotten up in 6 hours. Maybe we do care about you as a person. We're going to give you free food over there so you can walk over there and eat and then come back and spend more money. So, you know, that's going to incentivize me to continue to do business with this company. So like I said, some of the stuff is Big Brother. There's a region in China that's very into surveillance of their citizens, and they've been doing this for a while, but their goal in China is within 3 seconds to be able to identify a citizen. every citizen within 3 seconds. So they've had these surveillance cameras mounted on, different devices on their street, etc. But now the police are able to identify the citizen and see what type of record and background and things there are. There was also a year or two ago where technology was deployed in India, kind of like a precog system. Who saw Minority Report? So remember how there's those 3 very, very sad humans that could identify the future, and like one was the tiebreaker, kind of like if vSAN cluster failed, like it's tiebreaker. And so like there's that whole, issue, is that really true, right? And so in India they deployed this system where they thought they could do precog around that person is going to commit a crime, not even identify, but is that person going to commit a crime? It was like a trained area. So there's also in the UK a set of police officers that are using this type of technology to be able to identify people in crowds and like large events to say, oh, you are a criminal in our known database. Well, remember, let's go back to you're only as good as the data you're trained with. You're only as good as the team that's creating it. So the folks in the UK, they had an event of like 3,000, I don't know how many people were at the event, but they had like 3,000 identifications of humans, and about 2,600 of those were wrong. So imagine that you're arrested because there's this facial recognition that says you're, a criminal, and you're not. And also when it comes to people of color, imagine that that because we don't train with those data sets either, that people of color are 5 times more likely to be misidentified as a criminal with this type of technology, which is awful. All right. And then there's advertising. Since I'm in Silicon Valley, I assume everybody knows how to do this. But so we had an internal machine learning conference at VMware, and we had a gentleman who was on the Facebook ML team for advertising come in and speak to us for an hour about what their approach is and how they keep people on the platform. I personally don't use Facebook, and so I felt a little ill by the end of that talk. But so they went through like every opportunity that they take, and they identify, what does this person click on? What does this person look at? What does this person follow? How long did they watch this video? How long, how do they continue off in this direction? And so it's really about understanding that customers so that their platform is sticky, but also so they have better services to the people that advertise for them. So obviously I'm not a contractor and I do not need insurance, so this would probably never show up on my feed if they're doing a good job. And then there are so many more examples. So healthcare, it was very interesting where there was, I talked about that Snorkel tool where you use machine learning to identification. And so somebody was training a data set around x-rays and scans, and it said, how do we identify, I'm sorry, it wasn't around x-rays and scans, it was an MRI image of a heart. And so they were looking for faulty valves. And so they used this ML to train to identify where is this faulty valve in the heart. And they put through, thousands of images, and finally they thought the model got it. Well, what the model learned on was when they found an image that was a faulty valve, they put a little note on the bottom of the image. So the model trained on, is there a note? Yes, it's a faulty valve. So when they brought in the new data, of course, the model failed, right? But obviously, there's lots of good possibilities there. Obviously, if you're a company that does data and backups for other companies, you just have so much information across so many different lines of business. We already talked about hardware, software performance, airplanes, black holes. Obviously, everybody knows that we have a real picture of a black hole, but there's machine learning algorithms out there to identify the age of black holes. So there's just so many uses. And games, you always hear about games, but the reason for that is video games are a controlled environment. They're a controlled environment where we know the parameters, but also it's something that a computer can do thousands of times in a matter of minutes. A computer can play 1,000 games of chess in 15 minutes against itself, so it's a really good environment for it to learn. And so that example about how computers learn and act differently than humans, who's played that game Q*bert, like way back in the day? Maybe some of you are too young, but there is this game called Q*bert on this platform called an Atari back in the Stone Age. And the game was basically you had to hop up a pyramid with a little thing, and you had to jump on the right spots. And so this game has been around for like 40 years or something, right? And they just did some ML training to see if the model could learn to play Q*bert. And so this game has been around for 40 years. Let me stress that, 40 years. And when the when the computer started to learn to play this game, it found an exploit in which it could finish the I guess you'd call it the level in no time at all. No human in 40 years have ever tried that movement, because as humans, we think we need to jump from this box to this box to this box, and the computer only knew I need to jump left, right, up, or down. Those are all my options. It doesn't know that there's boxes because it doesn't think like us. It just knows that these are my instructions, and I'm going to do it until I win. So remember that as you're creating your ML models, you might not intentionally, you might accidentally do something. The computer might do something because it just thinks differently than us. It doesn't have the same constraints that we do. It doesn't understand that this is a whiteboard and this is a wall and they're only used for certain things. It doesn't understand ethics. It doesn't understand being good versus being bad. Tech is inherently neutral, but the way that we implement, the way that we train it, and the way that we bring it to the world, that's what causes problems, or that's what does great things. So hopefully all of you in this room, that code stuff, go out and do amazing stuff. Just find a pattern, find something you already have the data, there's zettabytes, and go do it. So thank you. I think that's it, but I'll hang out for any questions.